Alright, this time we're going to do a rotation around the y-axis. So I've just written down the formula from the previous page for rotation around the y-axis. Okay, so the thing we notice here is that we're going to have to do everything dy, and we need an expression for x and then dx dy. So we need to get our equation and do some preparation work down here. We need to get our equation in the form x equals, which is obviously going to be cosh inverse of y. And we need dx by dy, so we have to differentiate this thing. Okay, and that's one you can just look up on your formula sheets, or if you have a look on the work we did on the last thing, integral calculus sheet 1, you'll find that we dealt with those z squared over a squared things. So that's what the derivative for that is. And the other thing is we need our limits to be in terms of y. So we have when x equals 0, if x equals 0, y equals the cosh of 0, which is 1. And if x equals 1, it's y equals 1, y equals the cosh of 1, which I'm just going to leave as cosh 1, because I strongly suspect that if I stick it back into cosh inverse, it'll come out to be something sensible, but I'm not 100% sure about that, but let's not make it into a decimal too early, so excuse me, we'll leave it as that. So these are all our bits and pieces that we need to stick into our equation. So let's do some sticking in. So the area equals the integral from y1, which is 1, to y2, which is cosh of 1, times x, which is cosh inverse of y, times the square root of 1 plus dx by dy, which is 1 over square root of y squared minus 1, and all that bit has to be squared, dy. Which gives us, what we've got here, we've got integral from 1 to cosh of 1. Okay, again we're going to try and sort out what's going on inside this square root. So if we square that, we're going to get 1 over y squared minus 1, make it a common factor. This is going to be y squared minus 1, so we have y squared minus 1 plus 1 is just y squared, like so, which is the same as oops, I've lost my 2 pi at the front of the whole thing. I'll lose that again. 2 pi 1 to the cosh of 1. Square root of y squared is just y over square root of y squared minus 1 times the cosh inverse of y dy. Okay, so what we've got here is we've got what looks like a product. So if you had a product rule for integration, you'd be sweet, but we don't have a product rule for integration. Well, notice this thing will differentiate reasonably easy because the top happens to be pretty close to the derivative of the inside bit of the bottom. So that thing's doable by substitution. But joining the whole thing together, we use a technique called parts, which you may or may not have met yet, but if you haven't, don't panic because it's part of the next lecture. And so when you move on to the next lecture, it'll show you how to do this integration. So at the moment, I'm just going to put down the answer, but that whole idea of integration by parts we'll show you in the next lecture. So it's 2 pi, and it comes out to be square root of y squared minus 1 times cosh inverse of y minus y is what the whole thing comes out to be, between 1 and cosh of 1. Okay, so that step from here to here is what we call integration by parts, and like I said, I'll show you how to do that, and I think it's the very next lecture, but it may be the one after. Okay, so now it's just a matter of sticking the things in, so we get 2 pi square root of cosh squared of 1 minus 1 times, here you go, so cosh inverse of cosh of 1 is just 1, minus cosh of 1, and then we get to stick 1 into this whole thing, so 1 minus 1 is 0, so it all goes away, just going to be negative 1. And you could leave it like so, or you could stick it into a calculator, in which case it comes out to be 3.97, I believe is the answer. And it'll be in units squared because it's a surface area. Okay, so we found the surface area of the curve generated, of the surface generated by rotating this curve around the y-axis, and the big black hole in here is the integration by parts, which is something to keep your eye out for in the next section.